Hello, this is your 7th grade tutor going over lesson number 8. So, for this expression, what we're going to do is we're going to start out with our FOIL method so that we can actually figure out what this answer is. So, what this is you multiply your first, you multiply your outer, you multiply your inner, and you multiply the last. If we color code it, it'd be like this. So this would be your first, this would be your outer, this would be your inner, and this would be your last. If we follow this kind of steps, we'll be able to get our actual product. So let's start with first, 2n times 4n, 8n squared. Now let's try outer, 2n times 1, plus 2n. Inner, 3 times 4n, well that's just 12n. Last, 3 times 1, which is just plus 3. Now since this and this, they share like terms, what you can do is you can add them together, creating 14n plus 3. And that's your answer, 8n squared plus 14n plus 3. Moving on. Now you want to solve for the equation. The variable that you want to solve for, in this case, is x, because that's the unknown value. You don't know what x value is. So what you have to do is you have to make x by itself equal to a certain value. So what you have to do is you have to add x on both sides. You get 2x plus 3 is equal to 4. Now you want to make x alone. So what you have to do is you have to get rid of this 3, minus 3 on both sides. And you get 2x is equal to 1. X is still not alone. So what we have to do, we have to divide 2 on both sides. So that x is finally alone, and you get your value, 1/2. Moving on. Now, it asks you to simplify the exponent expression. What this means is that for here, how many 3's are there? There are 2 3's, 3 times 3, multiplied by how many 3's? 1, 2, 3, 4, 5, 6. There are 6 3's that are derived from 3 to the 6th power. There are 2 3's when there is 3 to the 2nd power. So in total, how many 3's are there? Well, there is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 3's in the entire equation. And if you multiply all of them, this would equal 3 squared times 3 to the 6th power. And this would be your answer. Furthermore, because this method can get a little tedious, what you can do is when you have an equation, when you have an expression like this, when they have the same base, which is the number that holds your exponent, if they are constant and if they are same, then what you can do is you can just add the exponents together. And as a result, you get 3 to the 8th power, which is equal to this. Moving on. Now let's try this. Which expression is equivalent to negative 9 to the 6th power? Let's try A first. Negative 9 to the squared, negative 9 cubed. If we multiply these together, you get negative 9, 2 plus 3, which is equal to negative 9, 5. Is this equal to this? No. So we know that A is wrong. Let's move on. You have negative 9 times negative 9 to the 5th power. Same idea. Negative 9. Since they have the same base, you can just add the exponents together. Negative 9 6th. Is this equal to this? Yes. So you know that B is one of your answers. Now to make sure, you can always check the other answers. Negative 9 to the 4th power to the 2nd power. What this means is that since there's a second power, that means that this is going to be raised by 2. So what you can do in these situations is that you can actually multiply the exponents. When this exponent is raised by an exponent, you just need to multiply them together and you get -9 to the 8th power. Is this equal to -9 to the 6th power? No. So you know that C is wrong. Let's try the last one. -9 to the 3rd power to the 3rd power. Now careful. Even though the exponents are together, that doesn't mean you're going to add them together. You're going to multiply them together. Because what this basically means is that you're cubing -9 to the cubed power. When you multiply this all out, you get -9, 3 plus 3 plus 3. And then as a result, you get -9 to the 9th power. Is this equal to -9 to the 6th power? No. So you know D is incorrect. So that means that B is the only correct answer out of all of these choices that is closest, that is equal to -9 to the 6th power. Well, that's about it for today. I hope you have a wonderful day.